All right, welcome. Today we're going to dive into one of the oldest and honestly most famous ciphers in all of history, the Caesar Cipher. By the end of this, you'll know exactly how it works, how to use it, and why this really ancient technique pretty much laid the groundwork for all modern cryptography. So let's kick things off by jumping way back in time to a problem faced by one of history's most famous leaders.
So, I want you to picture this. You're in ancient Rome. You are Julius Caesar, a general, out on the campaign trail. You need to send a supercritical order to your troops, but you know enemy spies could intercept it. So what do? How do you keep your message a secret? In an age where very few people could even read, having even a simple way to scramble a message was an incredibly powerful tool.
Well, Caesar's solution was what we call a substitution cipher. And the core idea is just beautiful in its simplicity. You just swap each letter for another one. Now, with this specific cipher, the swap isn't random. Every single letter in your original message, what we call the plain text, is shifted a fixed number of spots down the alphabet.
And that fixed number, that's your secret key. It's the one piece of info someone needs to both lock and unlock the message. And history tells us that Caesar himself had a favorite key, a shift of 3. So an A would become a D, a B would turn into an E, and you just keep going like that down the line.
Okay, that sounds simple enough in theory, right? But what does it actually look like when you're trying to encrypt a real message? Let's get practical and see this whole process in action. Let's take the word hello and use Caesar's key of 3. So first letter, H. We shift it 3 places forward, I, J, K. Boom, H becomes K. Next up is E, which lands on H. The 2 L's both shift to become O, and that final O, it becomes an R. And just like that, our normal word hello is now the secret ciphertext, KOOR.
Now, if you've got a long message, you need a process you can repeat, right? So let's look at the rules that make this a consistent system, one that works every single time without any guesswork.
So here's the crucial question. What happens when you get to the end of the alphabet? I mean, if you need to shift the letter Y by 3 spots, where do you go? Well, the system has this really clever trick. It just wraps around to the beginning. So Y becomes B and Z becomes C. It's like a continuous loop. In programming, you do something called a modulo operator to handle this, just to make sure you always land on a valid letter.
This gives us a great idea of the simple logic you could use to write a computer program to do this for you. A machine would just go through character by character, check if it's a letter, apply that shift with the wraparound rule, and then convert it back. And what about spaces or punctuation? Well, it just leaves them alone. Simple as that.
So how does your trusted centurion on the other end actually read the message KHOR? Well, decryption is just the reverse. Instead of adding the key, you just subtract it. You take that K, you shift it back 3 spots, and you get H. The whole process is perfectly symmetrical.
You know, for its time, this was absolutely ingenious. It's so simple to understand and use, but that exact same simplicity is also its greatest weakness. You could even call it its fatal flaw. So think about it. For the English alphabet, how many possible keys are there? If you don't count a shift of 0 because that doesn't do anything, you're left with just 25.
An enemy spy who gets a hold of your message doesn't need to be a genius. They can just try shifting the letters back by 1, then by 2, then by 3, and so on. In just a few seconds, one of those attempts is going to reveal the original readable message. This is what we call a brute force attack, and it's what makes the Caesar cipher completely insecure today.
So let's just break it down. On one hand, it's super simple, it's historically important, and it's a fantastic tool for teaching the basic ideas of cryptography. But on the other hand, with only 25 keys, it's instantly broken by a brute force attack. It's also really vulnerable to something called frequency analysis, where an attacker just counts the most common letters to guess the shift.
So if it's so easy to break, why are we even still talking about it? Well, because you really can't understand modern encryption without understanding where it all began. The Caesar cipher is, without a doubt, cryptography's essential first step.
Yeah, it's a fundamental building block. It introduced these core concepts of plain text, ciphertext, substitution, and keys. Literally every complex algorithm we use today to protect our data online owes a little bit of a debt to this simple, ancient idea.
And this leaves us with a really fascinating question. If a single, fixed shift is just too weak, how do you make a substitution cipher stronger? How did cryptographers take this basic idea and evolve it? The answer was to stop using just one alphabet shift.
and start using many of them. The next major evolution was the Caesar Cipher, which actually uses a keyword to create a whole series of different Caesar shifts inside a single message. That makes it much, much harder to break. And that's really the next chapter in this incredible story, and it builds directly on that foundation that Caesar laid over 2,000 years ago.